Okay, so we're back talking about some of the sample problems from your 1.6 homework. So I'll try to get rid of some of my mess here. We're going to work your number 10. Question number 10 has a radical in it, and on these, step number 1 is to isolate the radical. So throw everything else to the other side and just have the radical on one side alone. So when we throw the negative x over, it's positive x, and the 10 over is minus 10. Then what you do, because it's a square root, we will square that. And a square and a square root will cancel one another out and just bring out the 5x. But what we do to one side, we have to do to the other side. Now, like we mentioned in the last video, is squaring is not distributive. I think I told you that in the last one, but I'll tell you here. Squaring is not distributive. You can't just say x is squared and the 10 is squared. Multiplication is distributive. So back in some earlier problems, we were timesing through by the LCD, and multiplication definitely distributes, but squaring does not distribute. You can check that out with some things, maybe some numbers that you're aware of, and try squaring two numbers. Like if we had 4 plus 9 squared, we cannot say that's 4 squared and 9 squared. Let's just try that. 4 plus 9 would be 11, 4 plus 9 is 13. And so if we worked it out that way, it'd be 169. So it should work either way if it's truly distributive. And then if we try distributing it and saying 4 squared is 16 and 9 squared is 81. Totally different answer, right? That equals what, 97. So not the same. We can't just square this and square that and get the same answer as what it would be if we worked it out. That'd be 13 squared, 169. So squaring does not distribute. So what are we to do? Oh, I've got such a mess on this page from the last video. But we have to FOIL this actually, or use the squaring pattern. We could say x minus 10 squared means x minus 10 times x minus 10, which would be, the FOIL method should work there. The first times the first, the outer times the outer, the inner times inner, and then the last times last. So you see how you get these middle parts. You do get the first term squared, x squared, and the last term squared, 100, but you get these extra middle terms. So that's what you have to watch for if you use the squaring of a binomial. So it is x squared, it is 10 squared, but it is also these two times together, negative 10x, and then doubled. So I recommend, if you're not already, kind of use that squaring pattern, see if you can commit that to memory and say, anytime I see a binomial squared, it's the square of the first, the x squared, these two times together, negative 10x, doubled is negative 20x, and then the square of the last plus 100. That'll be a quicker way without needing to FOIL it each time, but it's fine if you do. So we do have a quadratic equation, so I need everything on one side equal to 0, which makes that a negative 25x plus 100. Then we're now back to that quadratic work. We either factor or use the formula, and like I've said earlier, most of these do factor. So what equals 100? 20 times 4, oh, I mean 20 times 5, 25 times 5, sorry. 20 times 5 is 100, and that will work well for us here. We need a negative times a negative to get a positive on the end, and still get a negative in the middle. And when you FOIL that, you do get negative 25 for the middle term. So then set each factor equal to 0. And we get our two solutions, potential solutions, because you might remember sometimes the answers don't work. We have to check them back in the original problem. So it looks like I have potential answers of 5 and 20. And so you go back to the original problem. Let's plug that in. Let's see, we had a square root of 5x minus x plus 10 equals 0. So if we plug in the 25 times 20 minus 20 minus 10, or sorry, it's plus 10 equals 0. Is that true? That's 100 square root is 10 minus 20 plus 10. I believe that is 0. That does check out. So that answer is confirmed. Then we check with the 5, plugging in 5 where all the x's would have been in the original problem. Square root of 25 minus 5 plus 10. Does that equal 0? So 5 minus 5, that's 0, plus 10. 10 equals 0. Nope, that is not true. So that answer will not be part of our solution set. We'll only say the x equals 20 in our answer key. So the final answer, x equals 20, is the only one we can use there. All right, check those answers. Okay, number 11. I think I'll skip over 11 because it's very much like that last problem. So I'll move on to number 12, which is our last topic of this section. I think that's right. So the last, 5 problems on your homework are this, uses this idea of U-Substitution. So this is not truly a quadratic. It's not really a linear. It's these problems, none of these problems on this page fit into those categories, but they are quadratic in form, meaning that the middle term, something about the middle term, if it were squared, would give you this first term. So if we can just substitute or pretend that this part is U, use the letter that this book uses, and maybe most books, I'm not sure. You could see any letter though. It could be any simple letter. That just don't use X, because we use that a lot in the equations already. So something besides X to differentiate. So the book uses U. So if we call this U, and I'm going to make a note, I'm letting U equal x squared. If that is U, this is the square of that. Do you see, if x squared were squared, 2 times 2 would make x to the 4th. You know, you multiply inner and outer exponents. So if that term is squared, it is that. So if this is U, that's U squared. So we can rewrite this equation in a simpler form, calling this U squared minus 4, calling that U, minus 77 equals 0. And then we can solve that resulting quadratic equation with our formula or factoring. Let's see, 7 times 11 is 77. I wonder if that helps me out. If I do negative 11 and positive 7. So, yes, that gives me a negative 4 middle term. You can check that by the FOIL method. And then your solutions would be positive 11 and negative 7. Now, this is not the final answer though. These are the substituted or pretend solutions, you might think of them as. So you always have to go back and make amends for whatever you were saving up here for the U. U is really x squared. So we were sort of ignoring that U is squared for a minute, but now we have to go back in and make amends for that and say, oh, that variable is really supposed to be squared. So this is x squared equals negative 7 and x squared equals 11. And then we have to finish that work that we kind of put on hold by square rooting. To finish that, x will be plus and minus, you know, because when you square root, you have to say plus minus 2 solutions, square root of 11. And then over here, square root both sides. X will be plus and minus the square root of negative 7. Now, we can bring out the I, and we should do that to be more thorough, and then otherwise it doesn't reduce. I want you to notice that there are 4 solutions here. This is a 4th degree equation, so we should expect 4 unique solutions. Unless there's a repeated solution, I guess I should say that. You're expecting to account for that many solutions. All right, a positive radical 11, a negative radical 11, and a positive and negative of this answer makes 4. All right, so you may want to pause the video and just try this one on your own to fly solo on it and see, because it's exactly the same thing. I'm going to repeat that process for more practice with that. But, you know, just like I do in my lecture videos, if you want to pause the video and practice, it really does help you become stronger at it whenever you do your own thinking through it before I'm just kind of repeating the steps. So this one's very similar. We've got the middle term, we'll call that U, and then if I were to square x squared squared would be x to the 4th. So this is the square of that. So if I call this U, this will be U squared. So it is quadratic in form. So I'm calling that U squared. I'm calling the middle term U, and then minus 42 equals 0. This is also factorable into x plus 7, x minus 6. Set each factor equal to 0, and it changes the sign of those solutions to negative 7, positive 6. Then we always make amends for whatever we left undone. U is really x squared, so we have to change u into what it really is. X squared equals -7, and x squared equals 6. Then when we square root both sides, we'll have plus and minus of those solutions, right? Don't forget, squared means you're looking for two answers, and there's a plus and minus. Bring the I out of that, radical 7, just like the last one, huh? Very much like the last one. Then here we square root, and x is plus and minus radical 6 for our 4 solutions there. Now when you're doing yours, it may regenerate out values that give you fractional answers. I don't know if it will though. I feel like it'll regenerate. Everybody will have just 1 in front of your coefficient, so you probably won't get a fraction. But if you would need to rationalize the denominator to be in final form. We can't have radicals in our denominator. So if that comes up and you have questions, as always, reach out to me and I can do another example. Okay, moving on, another example of using U-substitution. Notice here we have this kind of repeating block in the middle. That's what I would call U here, because that's exactly like I said, repeating block there. It uses that same number, and if we were to square this middle term, 1/3 squared. Now I know you might be saying 1/3 squared has a 9 in it, but whenever you square and there's already an exponent there, an exponent to an exponent, those multiply actually. So 1/3 times 2 is 2/3. So this squared is this. So we can let this be u, and then this will be u squared. All of these have that same kind of thing. It's good to make a note that I'm letting u stand for this middle term, just to kind of have it in a handy place to see, a neat place. So when I'm done, I have to go back and make amends. I can look at that note that I've made. But this equation becomes u squared plus u, and then minus 6 equals 0. And then factoring, u plus 3, u minus 2 works. So giving me the solutions of -3 and +2. And again, those aren't the actual final solutions, because we always have to make amends for the part that we left behind, which is a lot more on this one. We got all this stuff. We still need to address this third power. We didn't touch that. And then we'll need to add 3 to finish solving for x. So we do those last things when we make amends for it. So instead of u equals -3, I have x minus 3 to the 1/3 equals -3. And x minus 3 to the 1/3, the u value, equals this 2. Then I solve those equations. Not easy on their own, even there. How do I get rid of this 1/3? You can raise it to the third power, because as stated earlier, exponents to exponents multiply. So 1/3 times 3 would just make a 1. So that's what we want, to get rid of that exponent. So now it's just to the first. What you do to one side, you do to the other side. So raise that also to the third. -3 to the third is -27. Then bring the -3 over. Plus 3 is -24. So there's one of our answers. Shoo, right? Same steps here. Raise this side to the third. This side also to the third. That cancels out your exponent, making just x minus 3. Then 2 to the third is 8. Plus the 3, x is 11. So two answers, -24, 11. And you might be wondering, hey, she's not checking those answers. And I probably should check my answers all the time, but you really wouldn't have to check them on this. We've not done anything that necessarily compromises the sign or to worry about, but it's a good idea just to always look back at your answer and make sure that it's reasonable, maybe, or that there's not something in the denominator, if it's a fraction, that would make it be 0, or a reason maybe that answer would not be usable. So it's good to always kind of check back, and if you're really good, you'll put these numbers one at a time in for x, punch those through your calculator, and really check them to make sure that they work.